So I was talking to this hardware engineer in a cafe in Palo Alto just last month.
Oh, right in the heart of it all.
Exactly. And he was showing me these, just breathtaking 3D renders of a humanoid robot.
The kind of stuff you see in movies.
Totally. Fluid joints, carbon fiber plating. It looked like it belonged in a Kubrick film.
Mm-hmm.
And he had that classic Silicon Valley optimism,
The disrupting labor algorithmic breakthroughs talk.
That's the one. He was looking at the screen like he was staring directly into the future. But then I asked him a really simple question. I said, when do you start the physical assembly?
How happened?
His face didn't just drop. It went strangely blank. He just sighed and pulled up a different tab on his laptop. It was an email chain, a long one, with a dozen local manufacturers. It was just a graveyard of too complex and, 6-month lead time for a single custom actuator.
6 months for one part. Wow.
He told me with this kind of hollow laugh that to get just one prototype limb built, he had to source parts from 4 different provinces in China.
Because no one in the States could do it.
Or would do it. He just looked at his expensive coffee and said, "We have the best code in the world, but we've forgotten how to move the metal."
That phrase, forgotten how to move the metal, that says everything.
It was such a jarring moment. We spent 30 years convinced that the clean work of software and finance was, the pinnacle of civilization.
And that the dirty work of bending steel and machining parts was something you just outsource and forget about.
We thought we were the architects.
Right.
And the rest of the world was just the construction crew. But standing there, watching him refresh an empty inbox, I started to wonder.
What happens next?
Yeah. What happens to a civilization that has the dream but has lost the hands to build it? What happens when the flesh of modernity, these humanoid machines that are going to run our world, can only be birthed in the East?
It suggests the center of the world isn't shifting because of a better ideology. It's shifting because of a more fundamental physical reality.
We are witnessing the moment where the power to imagine is being outpaced by the power to execute.
I think that's exactly right.
And that anecdote, it just cuts right to the core of what we're exploring in this deep dive. Our mission today is to really analyze this material reality that's shaping the future of technology.
Specifically, this global race for what's being called embodied AI.
Right. We want to zero in on how this foundation of physical industrial capacity has sort of quietly become the ultimate strategic advantage in this competition. For all of us listening, this isn't just about robots. It's about understanding which economic and governmental models are structurally better equipped to build the next epoch of technological power.
It truly is a study in contrasting priorities, isn't it? For decades, the narrative in the West has been fixated on abstract intelligence.
AGI.
Achieving artificial general intelligence, or AGI, primarily through, digital means, scaling large language models, scaling software. They've invested billions in the cloud.
Meanwhile, the East, and particularly China, has placed this enormous strategic bet on something else entirely.
On tangible physical intelligence, on robotics, and the comprehensive machinery you need to put that intelligence into action in the real world. So you have this stark strategic contrast. The West focusing on financial assets and abstract code versus the East focusing on physical industrial might.
Which brings us straight to this fundamental economic problem in the West.
Yeah.
The hollowing out. We've spent nearly 3 decades operating under this.
Well, this seductive narrative that financialization and service economies were a higher, cleaner, more advanced form of growth. But what was the real cost of that ideology?
The cost was deeply structural, and it went far beyond just losing manufacturing jobs. This narrative led to the hollowing out of the entire engineering culture itself.
So not just the factory floor.
No, not at all. It wasn't just that the factory moved, it's that the specialized, tacit knowledge required for complex physical production. How to mill a specific alloy to a microtolerance, how to design and tune a high-performance hydraulic control system.
The stuff you can't learn from a textbook. Exactly. Or how to integrate dozens of custom parts quickly. That knowledge just atrophied. The cultural premium shifted from building things to managing assets. Capital started chasing speculative short-term financial returns, not the slow, gritty, long-term investment needed for physical infrastructure and industrial mastery.
You can't solve a material science problem with a spreadsheet.
But we forgot that. You're suggesting that the real loss wasn't just physical capacity, but an intellectual capacity tied to the physical world.
That sounds like it.
Absolutely. The atrophy of the manufacturing base means that even when a brilliant engineer in Silicon Valley has a design, there's no immediate high-trust ecosystem to realize it. The institutional memory, that intergenerational chain of knowledge passed from a master machinist to an apprentice, is broken. And that's a massive impediment in the EAI race, where rapid prototyping and iteration are everything.
And the difference in pace, the difference in efficacy, it's just astonishing when you look at it from the perspective of someone actually trying to build something physical today. I've heard this difference distilled down to the people on the ground.
Well, let's consider a stark contrast. We can look at two engineers, let's call them Chen and Julian. Chen works in a bustling hardware district in Shenzhen.
Right in the thick of it.
When he needed a specific high-torque micromotor for a humanoid ankle joint prototype, he walked 2 blocks to a supplier he's known for a decade. He didn't just buy a part, he collaborated with them to fine-tune the specifications.
So it's a partnership.
A deep one. And within 48 hours, the component was integrated and the robot was testing its gait.
48 hours.
Now, contrast that with Julian. He moved to London to work in fintech. Julian spends his days optimizing high-frequency trading algorithms, moving digital gold, often with no real-world physical correlation. He moves billions, but he admits to feeling a sense of, well, he calls it phantom limb syndrome.
Phantom limb syndrome.
He's surrounded by massive wealth and financial instruments, yet he cannot point to a single physical object he has helped bring into being. Chen is building the future, while Julian is optimizing the system that distributes existing wealth. The implication is profound. When AI finally takes physical form, it will be born in the places where the grease and the gears actually exist.
Not in the places optimized purely for digital leverage.
Exactly.
That anecdote just perfectly encapsulates this philosophical difference between manipulating virtual wealth and creating tangible value. When we talk about systemic financialization in the West, we're seeing wealth increasingly obtained through rent-seeking, the finance, insurance, and real estate sectors fight fire. It's creating this virtual wealth that's increasingly detached from physical production. But what are the policy mechanisms that allow financial engineering to consistently overshadow industrial engineering?
Well, the underlying dynamic is a major economic reversal from the industrial era. Industrial capitalism, as described by Marx, it followed the MCM loop, money invested to create capital, which produces commodities, C, yielding more money.
And that process was rooted in tangible production.
Absolutely. Today, in highly financialized economies, that process is abbreviated to MM. Money is made purely from money and credit, without any significant tangible capital investment.
So instead of investing in factories or R&D that would give you better products, the capital gets diverted purely into financial instruments.
Precisely. And this shift, it manifests most clearly in corporate behavior. You see companies earmarking these immense portions of their corporate income, often over 90%, to boost stock prices through dividends or, more commonly, through stock buyback programs.
I've even heard of companies actively borrowing money just to buy up their own shares.
It happens. They're effectively raising corporate debt ratios instead of investing in new research or workforce training or scaling their means of production. It's a short-term gain for shareholders that starves the company's long-term industrial capacity. It transfers wealth from future innovation to immediate financial returns.
And this focus on financial engineering also creates these systemic costs that make building things in the West just prohibitively expensive.
Oh, absolutely. The heavy debt leveraging in the FIRE sector, especially real estate and finance, it inflates asset prices dramatically.
Wow.
When housing prices and commercial property are inflated on credit, the cost of living and the cost of doing business just skyrocket.
Right.
And that financial overhead leaves less wage and profit income available to spend on actual goods and services. It's a mechanism that benefits those who already own assets, the rentier class, but it simultaneously imposes debt deflation and rising operational costs on the real economy, which makes local manufacturing non-competitive.
So while the West has been optimizing its MM loop, the East has taken a fundamentally different strategic position. It's rooted in prioritizing the real economy, the production of tangible goods and services, as the bedrock of its economic strength.
That view is deeply strategic, and it's rooted in an analysis of global vulnerabilities. It's heavily influenced by President Xi Jinping's economic thought, which was shaped by observing how that excessive reliance on the virtual economy led to the crippling systemic risks we all saw during the 2008 global financial crisis.
So this is a direct lesson learned.
It's a core lesson. The policy repeatedly emphasizes the deep integration of the digital economy with this tangible, real economy. For China, economic strength must be founded on production. They see wealth not as purely abstract financial assets, but as the ability to command the physical output of goods, which is the exact foundation required for this next technological leap. Embodied AI.
All right, let's transition now to that technological leap. We're moving beyond traditional AI. We need to understand the specifics of embodied AI, or EAI. You mentioned it's not just about thinking, it's about doing.
That distinction is absolutely key. Embodied AI refers to AI-powered hardware systems that possess the capability to perceive and interpret multimodal inputs from the physical environment site, sound, touch, force, and then use that information to make autonomous decisions and carry out physical actions in the real world.
Okay, so what's the difference between EAI and, say, a standard industrial robot, which has been doing things on assembly lines for decades?
The difference lies in the level of autonomy and cognitive integration. A conventional industrial robot, it performs pre-programmed repetitive tasks in a highly structured environment. It does one thing over and over.
Right.
An EAI system, conversely, integrates advanced software, intricate control systems, and very rich sensors, often drawing on large language models as the reasoning and linguistic backbone to adapt to dynamic, unpredictable, real-world environments. It can generalize tasks.
So humanoid robots are just one physical form of this.
Exactly. Humanoids are one form of EAI, but the concept also includes sophisticated drones, autonomous vehicles, and highly adaptive industrial manipulators. The common thread is that the intelligence is fundamentally tied to a physical body that interacts with the world.
And this is where China's strategy really diverges from the prevailing focus in the U.S. The U.S. is all about scaling digital AI, chip design, but Beijing is betting that true dominance requires physical embodiment.
Their bet is that true AI dominance will be secured by systems capable of autonomous operation in the physical world. And this is a deliberate policy effort to translate the immense advances in generative AI models like DeepSeek R1 directly into the real economy.
So for Beijing, the physical interaction isn't just an application of the AI.
It's a prerequisite for AGI. They believe true general intelligence requires the ability to interact with and learn from the physical world, to accumulate the kind of common sense knowledge that you just can't get purely through text or digital data.
It's the difference between reading every book in the world about how to ride a bike and actually getting on one and learning.
That's a perfect analogy. One gives you knowledge, the other gives you physical intelligence. And we are seeing real-world demonstrations of this strategy being deployed rapidly in key industrial sectors.
So tell me about the factory floor examples. Are these just pilots, or are we talking about integrated solutions?
They are moving very rapidly into integrated solutions. Look at Zekker, a major Chinese EV manufacturer. They have already deployed advanced UB-Tech robots, powered by a multimodal reasoning model based on DeepSeek R1 as a coordinated team on the factory floor.
A coordinated team of robots?
Yes. And these robots aren't just welding. They're performing complex, generalized tasks like lifting boxes, fetching specialized parts, and performing quality checks that require subtle, tactile, and visual interpretation in a demanding, fast-paced industrial setting.
Which proves the technology is already transitioning from R&D into serious industrial utility.
It's happening now, and the focus on continuous operations suggests they are thinking about how to maximize the value of this embodied labor.
What do you mean?
Well, the Walker S2 is the perfect example of thinking about the industrial implications beyond the immediate task. UB-Tech unveiled this humanoid robot that can autonomously change its own batteries.
It changes its own batteries.
Exactly. On the surface, that sounds like a minor efficiency detail, but in industrial terms, it's functionally transformative. It allows for potential uninterrupted 24-hour operation on the factory floor without any human intervention for refueling or charging. This single capability dramatically boosts the return on investment in manufacturing and logistics by maximizing uptime.
It's an example of practical industrial thinking driving the robotics design.
It is. And this commitment isn't just coming from private industry. It's codified in the highest levels of governance.
It's front and center in their planning.
Absolutely. Embodied AI was explicitly listed in the March 2025 government work report alongside other nationally critical technologies like quantum and 6G. This signals that EAI is seen as a core tool for betting the industries of the future.
And it's in the 5-year plan.
Furthermore, yes, the CCP's Central Committee has recommended incorporating EAI as a new driver of economic growth in the forthcoming 15th five-year plan. This ensures long-term coordinated funding and governmental support, confirming that this is viewed as a sustained, decades-long strategic bet.
You also mentioned that key scholars argue that EAI isn't just an application of AGI. It might be the route to AGI itself. What is that philosophical argument?
It's this notion that interaction with the physical world is non-negotiable for true general intelligence. LLMs provide a powerful linguistic and reasoning foundation, but they are limited to the data they were trained on.
They're disembodied.
They are. Human general intelligence is fundamentally embodied. We learn by manipulating objects, experiencing gravity, sensing temperature, navigating 3D space. EAI allows the AI system to learn in the same way through iteration and physical consequence. Scholars argue that EAI offers the most promising path toward replicating the full spectrum of human capabilities, integrating abstract reasoning with practical physical dexterity. This elevates the pursuit of robotics from mere automation to a fundamental quest for cognitive superiority.
But that ambition to achieve true general intelligence through physical interaction, it can only be realized if you have an industrial base capable of building the hardware and building it quickly and cheaply.
Right.
And this is where the structural problems of the West meet the structural advantages of the East. China's decades of manufacturing prowess is now its killer app for EAI.
It's an undeniable, almost insurmountable advantage. The robust hardware manufacturing base and the comprehensive supply chain density. It's just on another level. Decades of deliberate industrial policy, building everything from basic textiles to highly advanced EV batteries, created this incredibly dense industrial fabric.
So component makers, specialized foundries, suppliers, assembly plants, they're all clustered together.
Often within a short truck ride of one another, unlike the fragmented global chains the West relies upon.
That proximity and vertical integration must fundamentally alter the speed of development. How does that translate into tangible advantages for a robotic startup?
It translates directly into velocity and cost. This density allows robot startups to dramatically accelerate their prototyping cycles. If you need a custom run of high-tolerance aluminum parts or a specific wire harness, you can go to a supplier across town, get the part in 48 hours, integrate it, test it, and iterate.
Instead of a 6-month lead time.
Exactly. Western competitors often face lead times measured in weeks or months just for a single custom component, and this integration results in a staggering production cost advantage. A complex 6-axis arm or a bipedal prototype can sell for 30 to 50% less than a comparable Western build.
Wow.
That combination of high speed and low cost is why China installs more factory robots each year than the next 4 countries combined.
Let's talk about that scale. What does the current infrastructure look like in terms of capacity? It sounds like we're far beyond just capacity. We're talking about density.
We are talking about density and strategic market control. China currently runs the world's most extensive installed base of factory robots. We're talking roughly 1.7 million units.
1.7 million.
This gives it a density of about 470 robots for every 10,000 manufacturing workers. That surpasses Germany and Japan, which we traditionally think of as the automated leaders.
And crucially, they control the supply chain for the components.
That's the key. China controls approximately 63% of key companies in the global supply chain for humanoid robot components. This control over the parts ensures price stability, resilience against geopolitical shocks, and the ability to dictate technical standards globally down the line.
You mentioned the EV boom earlier. How does the expertise gained in electric vehicles directly benefit the creation of advanced humanoids? That seems like a massive technological synergy.
It's one of the biggest hidden advantages. China owns roughly 3/4 of the world's battery cell capacity. This massive know-how transfer is just vital for robotics.
How so?
Well, first, EV technology provides higher density chemistries, which translates into longer operation times for robots. Second, the expertise allows for the rapid engineering of flexible and custom-shaped battery packs that can fit into the very tight spatial constraints of a humanoid design.
And third,
the advanced battery management systems, the BMS, originally developed for controlling complex EV charging and discharge cycles, are now adapted to monitor the load, temperature, and performance of robot power systems in real time. That dramatically boosts safety and performance on the factory floor.
And then there's the foundational advantage of resource control and proximity to raw materials.
That's the structural moat that is so difficult for competitors to replicate. China controls about 60% of global rare earth output, including neodymium and dysprosium. These elements are absolutely critical for domestic motor and sensor makers.
Especially for the strong magnets you need in high-torque servo motors and actuators.
Exactly. The presence of these material suppliers, component vendors, and contract manufacturers cluster along the same coastal corridors further shrinks lead times and keeps inventories lean, adding immense resilience to the entire EAI ecosystem.
Okay, so given this overwhelming advantage in manufacturing, where does the industry still trail the West? Where are the bottlenecks that China hasn't solved yet?
The industry still trails the West in two critical, highly complex areas. First is access to the absolute cutting edge of advanced AI chips and compute power necessary for training and rapid inference. That is, running the large multimodal models used in EAI systems.
The highest-end chips.
Yes. While domestic chip production is advancing, the highest-end, most performant chips are still challenging. Second, there is the need for high-precision multidimensional sensors, particularly 6-axis force sensors and torque sensors.
Wait, why are those sensors such a bottleneck? They sound like basic components.
They are anything but basic. High-precision force sensing requires incredibly specialized materials, highly complex calibration algorithms, and micro-machining capabilities to measure force across all 3 spatial axes and all 3 rotational axes simultaneously.
Which is essential for delicate manipulation.
Essential. Like a robot safely handling an elderly person or accurately assembling parts with very tight tolerances. The challenge lies in achieving long-term reliability and high sensitivity at a low cost. While domestic production of many other critical components, motion control, servo drives, reducers, has achieved near international parity, these specific sensors still show a reliance on Western imports.
But they're closing the gap.
Aggressive state investment is rapidly closing this gap, yes.
So we have the economic pivot and the manufacturing base. But the third element, as you highlighted earlier, is the ability of the political system to actually organize and execute these massive long-term technological transformations. This brings us to the profound institutional divide. Western manufacturing paralysis caused by vitocracy versus the Eastern focus on state capacity.
This institutional difference often dictates the speed of innovation deployment, which, in a fast-moving field like EAI, is arguably more important than the initial invention itself. Vitocracy, the system where countless stakeholders, interest groups, and legal mechanisms hold veto power, fundamentally prevents systemic progress and the completion of large, complex, long-term industrial projects.
I can feel the pain of that engineer in Palo Alto again. It's what makes building a new subway line or a complex industrial facility take a decade or more in the West. It's a paralyzing friction.
It creates systemic regulatory drag. I mean, think about this comparison. I was reading about an urban planner, we'll call her Sarah, who was trying to facilitate a new robotics innovation hub in a major Western city. For 3 years, her project was locked in what they call vitocracy.
An endless loop.
An endless loop of public hearings, environmental lawsuits over minor setbacks, and fragmented regulatory hurdles from 5 different local agencies, each demanding slightly different compliance standards. Every stakeholder had the power to say no, but no one had the institutional authority to say go and enforce the timeline.
Honestly, hearing Sarah's story makes me feel exhausted. We assume our regulatory oversight is a sign of freedom, but perhaps we've regulated ourselves into a coma.
Now contrast that with the account of Director Wu, who was tasked with overseeing an industrial park in the Yangtze River Delta, specializing in EAI. In his environment, the local government and private robotics firms shared a singular roadmap. Infrastructure, energy grids, and regulatory clearances were synchronized before the first foundation was laid.
Wow.
The transition from a laboratory concept to a mass production humanoid line happened in months. Director Wu's success is a function of state capacity, the ability of the government to define and execute long-term strategic goals with speed and unified authority, minimizing internal opposition.
And this concept of the developmental state seems to be the engine behind Director Wu's speed. Can you elaborate on that model?
The developmental state is an East Asian model focused singularly on economic development. It utilizes strong state intervention, extensive regulation, and long-term planning. It is designed to have the political will and the institutional authority to enforce long-term economic guidance and resist internal opposition from groups protecting narrow, short-term financial interests.
So it's different from the Western regulatory state.
Very. The regulatory state primarily enforces standards to prevent market failures. The developmental state proactively promotes and guides the growth of specific targeted industries like EAI.
And this model has deep, successful historical roots. demonstrating its efficacy beyond just China.
Oh, absolutely. We saw this historically in Japan with MIT, which strategically guided their industrial growth. Or look at Thailand's use of aggressive state tools. They placed massive tariffs up to 150% on automobiles to enforce import substitution and protect nascent domestic industries.
In the 51% rule.
At the same time, they mandated that foreign auto industries forming a joint venture in Thailand must give the Thai company a 51% stake. That rule ensured that jobs, know-how, and profits stay domestic. Singapore is another classic example, using institutions like the Vocational and Industrial Training Board to match worker skills directly to planned national economic development needs, ensuring a ready and tailored labor supply.
So China's current EAI strategy applies a devolved variation of this model. It's not just one central plan, but rather an intensely competitive, localized approach.
It's the pilot first, scale later methodology, which they've perfected since the 1980s. Local governments are encouraged to experiment with development strategies and then scale the most successful policies nationally. This encourages intense regional interprovincial competition, sometimes bordering on redundancy.
And this leads to clear regional specializations within the EAI supply chain.
Exactly. Beijing, leveraging its strength in AI chips, prioritizes high-performance computing tailored for EAI. Shanghai, home to leading sensor technology developers, focuses on core hardware components like LiDAR and high-precision sensors.
And the manufacturing hubs.
Meanwhile, manufacturing and integration hubs like Guangdong and Zhejiang focus on the complete EAI platforms, specifically multi-purpose humanoid robotics. These regions are allocating staggering funding. Beijing, for instance, launched a fund worth over $14 billion over 15 years to support these specific technological tracks.
While that interprovincial competition seems beneficial for generating breakthroughs, as we saw with their incredibly rapid development of the EV sector, does this devolved approach risk resource duplication and inefficiency?
It absolutely carries risks. Resource duplication and local government debt loads, driven by ambitious past infrastructure and manufacturing investment targets, are ongoing concerns. However, the prevailing view is that this intense competition often generates the genuine breakthrough technological progress necessary for national scaling later.
So the state accepts some local redundancy.
In exchange for guaranteeing that multiple innovation pathways are explored simultaneously. The key is that once a clear technological winner emerges, the developmental state has the capacity to enforce national scaling and standardization.
We've covered the technological and governmental mechanics, but let's talk about the soul of this effort. There's a deeper cultural and philosophical component driving this shift, the inherent value a society places on the act of creation itself.
That's the cultural backbone. There is a deep-seated belief in the concept of the she economy, the real, the practical, the tangible, which is valued over the perceived emptiness or exa of certain financial services or highly abstract wealth.
So if your work doesn't lead to a physical outcome, it can be culturally viewed as empty or vain.
That's the idea. So high finance or certain consulting roles, which primarily shuffle existing assets or optimize processes without creating physical goods, might be viewed with less dignity than the engineer on the factory floor.
So the objective of software or digital innovation in this context must lead to something real.
It has to, like advanced robotics, EVs, or industrial machinery. The machine humanoid, taking over the heavy lifting of the labor economy, is the ultimate physical manifestation of that cultural value. This inherent cultural valuation places dignity, merit, and national purpose in physical construction and industrial mastery.
And this focus on the tangible must be empowering a whole new class of engineers.
It is powering a resurgence of the engineering meritocracy. Imagine an engineer, let's call her Lynn, a robotics engineer in Shanghai developing humanoids for elder care. Her work is viewed not just as a profitable venture, but as foundational social policy.
It has higher purpose.
Exactly. She finds dignity and fulfillment in mastering the machine and contributing directly to the real economy. Her work is a primary driver of cultural resilience, ensuring that as China's workforce shrinks due to aging, the quality of life doesn't collapse. She sees her Western peers gravitating towards sectors she views as derivative law, digital marketing, asset management, while she is trained to believe that the highest calling is solving tangible, physical problems.
That is the secret sauce we often miss. A society that derives its dignity from solving physical problems will outbuild the society that derives its dignity from financial arbitrage.
It's a fundamental difference, and this commitment to EAI is not just about abstract technological leadership. It's a direct, practical response to massive impending demographic and economic challenges.
It's a response to China's rapidly aging population and rising labor costs.
Absolutely. We are seeing a major shift. Younger generations are increasingly reluctant to work in traditional factory settings, the 3Ds: dull, dirty, and dangerous. This makes the once cheap labor pool less affordable and less available.
So EAI systems are designed to directly substitute for human labor in these undesirable or hazardous tasks.
Exactly. And crucially, as Lynn's work suggests, they are also being developed to provide pervasive quality elder care services, easing the burden on the shrinking working age population.
So robotics and automation become essential tools for maintaining social stability and avoiding a productivity collapse.
That's the goal. The immediate tactical goal is to significantly boost productivity in key industries like manufacturing, logistics, and construction, which are critical to revitalizing slowing economic growth. The China Academy of Information and Communications Technology views EAI as capable of revolutionizing human-machine collaboration, allowing autonomous systems to learn from human workers through natural language and motion, transforming production lines, and securing long-term economic resilience against demographic headwinds.
They're automating their way out of a crisis.
In many ways, yes.
Let's pivot to the highest stakes. If this strategy is successfully executed, if China successfully develops and scales commercially applicable EAI systems ahead of other countries, what are the long-term geopolitical and economic ramifications?
The central consequence would be the global supplier dilemma, and it is potentially more profound than anything we've seen before. If China becomes the dominant, high-speed, low-cost supplier of EAI, it will create a level of global reliance across critical economic sectors, manufacturing, logistics, healthcare, service industries, that could surpass previous dependencies on, say, 5G networks or solar panels.
Because EAI is a truly foundational technology. I mean, if your hospital uses Chinese-designed robot nurses, or your logistics chain relies on Chinese autonomous forklifts, the dependence is systemic.
It's systemic. Access to these EAI systems will determine a country's future economic competitiveness. If Western nations rely on imported EAI technology, they concede control over the physical execution layer of their economies. And China is already laying the institutional groundwork for this global diffusion through initiatives like the Global AI Governance Action Plan.
Positioning itself as the partner best equipped to deliver practical, physically embodied AI applications.
Tailored to the development needs of other countries, especially in the developing world.
Yes. Beyond the economic sphere, how does EAI translate into a transformation of military power?
The People's Liberation Army's official news outlet, PLA Daily, identifies EAI as a technology capable of redefining unmanned warfare. The vision is for EAI systems to become commander fighters.
Commander fighters.
Agile, autonomous systems that integrate multimodal sensors and large multimodal models to achieve a much higher degree of real-time tactical autonomy on the battlefield. Unlike current unmanned systems that are often remotely piloted, these EAI systems would be resilient to electronic warfare and capable of making complex tactical adjustments in response to changing battlefield conditions with minimal human intervention. They represent a fundamental leap in battlefield robotics.
This high-stakes race is what leads to the proposed U.S. restrictions on robotics exports. But is that action a sign of genuine competitive effort, or is it symptomatic of a deeper cultural problem?
Many analysts view these restrictions as symptomatic of the psychology of decline. When a civilization finds it can no longer compete effectively on the fundamental metrics of efficiency, cost, and industrial quality, it often resorts to changing the rules, attempting to cripple the frontrunner rather than accelerating its own production capabilities.
It's an admission that a culture has lost confidence in its own generative physical powers.
I think that's a fair assessment. And attempting to shore up supply chain security without tackling the structural issues seems like a strategy doomed to institutionalize inefficiency.
It absolutely risks cementing technological irrelevance. Attempts to reshore manufacturing without first dismantling the structural issues of autocracy, the regulatory fragmentation, the endless procedural hurdles, the tyranny of the interest group, will result in secure supply chains that are vastly inefficient and dramatically higher in cost. They will be unable to compete globally on price or speed.
The real conflict, therefore, is not just about competing countries. It's about the clash of economic systems themselves.
Can you elaborate on that fundamental conflict between economic systems? You described it as a struggle between finance capitalism and industrial state capitalism.
The core struggle is whether the economy will prioritize financialization that benefits the rentier class or actively build up the industrial economy for overall prosperity. Finance capitalism, fueled by that loop we talked about, focuses on maximizing asset price inflation and debt leveraging, leading to rents extracted by the banking and real estate sectors. This ultimately undercuts the industrial economy by raising operating costs.
And the state capacity model used by the East Asian developmental states is designed to explicitly check those rentier dynamics.
Precisely. Historically, the developmental state model has aimed to free its economy from rentier income, often by keeping banking in the public domain and controlling land use. Keeping money and credit creation public, instead of privatizing it and allowing financial firms to charge fees and extract wealth through inflation, is the most important step in keeping down the cost of living in business, which translates into industrial competitiveness.
Which allows the state to allocate capital strategically for long-term industrial projects.
Like EAI, rather than letting it be absorbed by short-term financial engineering. The state-led approach can also forgive debts for strategic enterprises deemed to be in the public interest, preventing widespread closures and maintaining industrial capacity, a tool unavailable in pure finance capitalism. This difference in capital allocation, short-term financial gain versus long-term physical investment, is the ultimate source of friction in the EAI race.
It's a completely different game.
Ultimately, the humanoid robot is the flesh of modernity. It represents the highest achievement of national will and industrial resilience because its creation requires the seamless integration of advanced algorithms with unmatched physical supply chain mastery. This mastery is not born merely in the cloud or in the financial markets. It is forged in the grit of material production, the discipline of engineering culture, and far-sighted state capacity. The civilization that masters the creation of this technology, the one that still remembers how to move the metal, will seize control of the next epoch of global power. The right to define the future belongs to those who can physically assemble it, not merely those who finance it.